is our computer networking project on CSMA-CD algorithm. So we implemented this algorithm using Python using object-oriented design principles. So for part 1, we see that there are two nodes which are connected to the same bus. So let's see the simulation for this. So we are displaying the status of the nodes. Node 1 is in transmitting and node 2 isn't ready. So at time 5, node 2 also started to transmit and there has been a collision. Both the nodes chose the same back of 6, so after 6 again there should be a collision. So after 6 again both the nodes are in collision. Now they chose a back off of 8 and 18, so after 8 node 2 should be transmitting and we can see that node 2 is transmitting. So this is about part 1. Now going to part 2. In part 2, 4 nodes are connected to the same bus. So we are given the flexibility for choosing the number of nodes. So all the status is showing up. So node 2 and node 3 started to transmit and so there has been a collision and they both went to the same back off. So again there will be a collision between node 2 and node 3. So you can see that there is a collision between node 2 and node 3. So at point 1, since node 4 also started to transmit, so node 4 is also in status of collision. And this is the back off time. So after back off 3, we should see that node 4 is transmitting and node 4 is transmitting now. So this is about part 2. We're going to part 3.
For part 3, we have come up with an UI. This shows the network which was given to us, where the squares are the nodes and the circles represent the router. This here shows the clock in millisecond, and this will show the different throughput. So let's start the simulation. So as we can see that the clock has started and one node A has started transmitting a packet to D, but B has also started to send it to C. So there has been a collision because they are on the same network. Now D has started sending a packet to C. If we come here, we can see that it is first transmitting it to the router. That's why R4 is the MAC address, and now R4 is transmitting it to C. The router takes this decision about where to send through the routing table. If we come here, we can see that R4 to send something to C knows that there's a direct connection to C. That's why it's forwarding it to C. This decision is taken based on Dijkstra's algorithm, based on the cost, and this table here shows the cost of the different edges. So for example, to send, if R1 wants to send something to C or D, it's choosing R4. That is because if we come here, we can see that the cost to R4 is less than than sending it to R3. So that's why the shortest path is through R4. Now this table, this values here shows the throughput. Now since A has sent some packets and D has sent some packets, so this shows the current throughput of both A and D. But since B and C hasn't successfully sent any packet yet, so that's why they are showing as 0. Yellow represents here that all the 4 nodes are waiting because of collision, and now A has got chance to send a packet to C and it is transmitting it to R1. Now R1 knows that it has to send to C and it checks against its routing table to see that it has to send to R3, which changed after 100 milliseconds. So now it has been updated to R4 and now it is sending to R4. And now R4 knows it can directly send to C. And we can see that the C's received packet count has increased by 1. And that's how this entire UI is working. Thank you.